All right, so in this video, we're going to talk about calculating the critical points. And for this one, we're looking at a two variable function. You can see we have f of xy. Okay, so a variable function with one where you have f of x equals, blah, blah, blah. But now you have f of xy, and which is equal to x cubed plus y cubed minus xy. Okay, so how do we go about finding the critical point and their nature? That's another thing, their nature. So when you mean by their nature, like they're asking, is it a minimum point? Yeah, it's a critical point now. Okay, now not asking about the nature, is it a minimum point, maximum point, or rather like a saddle point? You'll just say like a saddle. Okay, is it a minimum point? Is it a maximum point or just like a saddle area? Now, let's look at the function. We have f of xy equals this. So the first thing we have to do, okay, the first step usually, you know, find the derivative of the function with respect to each variable. Okay, we're going to find the derivative of the function with respect to x and with respect to y. So let's do it. Okay, let me use the word partial. Let me use the word the partial derivative, partial derivative now. Okay, so we're going to find the partial derivative of the function with respect to each variable. Okay, let's start with, I'll write it. There's so many ways you can write it. So I'll just write it like this. So the partial derivative del of, you know, f of xy, okay, with respect to x. Okay, so let's look at this. So when we're finding the partial derivative with respect to x, we focus just on x. Okay, we're going to focus on x, and then for y, so we can treat y as, let's say, as a constant. You would treat y as if it were a constant, or anywhere there's no x around it, you would say, okay, you would assume, so this y to the power of 3 now, you would assume there's an x there, but x is raised to the power of 0 because anything raised to the power of 0 is 1. So what I like to do is two things. Is either I assume that the other variable that's y is just a constant. I just assume it's a constant. So if I find the, okay, or where there's no x around it, I will just say, okay, it's x raised to power 0 because anything to power 0 is 1. So let's do it. So the let's start with this one. What's the derivative of, x to the power of 3? That will be 3x squared. Okay. There's no y, so we go to the next one. Plus what's going to be the derivative of y to the power of 3 with respect to x. So like I said, let's say we have x to the power of 0, y to the power of 3. What will be the derivative of this function with respect to x is going to be 0. Okay, it's going, because this 0 is going to come down here, it's going to multiply everything and give you 0. Or even if we take this y to the power of 3 as a constant, the derivative of a constant is still 0. So that's just going to be 0. I'll just add it there, just for, just so know that we find the derivative of the minus. Now we have derivative of xy. Okay, we ignore the y, focus on the x. And what will be the derivative of x? It's going to be 1. Okay, and what's 1 times y? Y. So this will be minus y. So at the end, we're going to have 3x squared minus y. So the derivative of this function with respect to x is 3x squared minus y. All right, so let's go to the other one. Let me come down here. Okay, the derivative of f of xy with respect to y now. Okay. So the first one we have x cubed. Like I said, you can just treat x as a constant to the power of your derivative will still be 0. You can just say this is y to the power of, x to the power of 3, y to the power of 0. What's going to be the derivative of this function with respect to y is going to be 0. So we have 0 plus what's the derivative of y to the power of 3 with respect to y? It's going to be 3y squared minus we have xy again, so we ignore the x and focus on the y. What's the derivative of y with respect to y? 1. It's going to be x times 1, which gives us x. So we have minus x. So it means that we have 3y squared minus x. Okay, so far what we've the two partial derivative that we've gotten, we have 3x squared minus y, 3y squared minus x. Okay, so what are we going to do now? What are we going to now? We're going to equate. So we now next thing is that we equate these partial derivatives to 0. Okay, what we equate these partial derivatives to 0. So we have 3x squared minus y equals 0 and 3y squared minus x equals 0. But why do we do this? Because at a critical point, there is no, I would say there's no change. And, there's no, this is a, let's say you have like a minimum points. Let me just draw like, just one like this. I'm going up and I'm going down. Okay, you can see this is going up. This is positive. This is going down. This is a negative, like, rate of change. But at a critical point, let's say at the maximum point, like there's no change here. Okay, I can't really get the exact place, but you know what I mean. So at a critical point, like here at a maximum point, the rate of change at this particular point is 0. So we just have to equate this to 0. Okay, then from there we can now find the values of x and y. Okay, now so it's gonna this is giving simultaneous equation vibes. All right, so let's start. Let this be equation 1 and equation 2. Okay, let's start with equation 1. Okay, equation 1. We have 3x squared minus y equals 0. We can actually move the y to the other side. So this means that 3x squared equals y, or we can say or y equals 3x squared. Okay, so what does this mean for us now? It means that we can actually use the substitution method. We can substitute, okay, 3x squared for y in equation 2. So where we see the y now, it becomes 3x squared. And in equation 2, we have 3y squared minus x equals 0. So this y now, we're going to substitute it. We're going to change it and put 3x squared. Okay, don't panic. It's not something serious. So we have 3. Okay, so we're going to replace this y with 3x squared. And remember, there's still a square outside. Minus x equals 0. Okay, stay with me on this. So we'll have to open this bracket. So this square outside will affect everything inside the bracket. So 3, what's 3 squared? That's going to be 9. And what's x squared to the power of 2? We're going to multiply the powers. That'll be x to the power of 4 minus x equals 0. Stay with me, stay with me. Okay, now we can open this bracket now, this outside, this big bracket. So 3 times 9 will be 27. So we have 27 x to the power of 4 minus x equals 0. Okay, how do we find x now? So what can we start to do? We can factorize using x because x is common between the two. So we can bring x out here. So what's 27 x to the power of 4 divided by x? That should be 27 x to the power of 3 minus x divided by x is 1 equals 0. Okay, x bracket 27 x to the power of 3 minus 1 equals 0. What does this mean? Just imagine if you multiply two numbers, a times b, to give you 0. It means at least one of them must be 0. Okay, if 8 times b gives you 0, it means either a is 0 or b is 0. Or both can be 0, but at least one of them must be 0. So it's the same thing here. So it means that here either x is 0 or 27 x cubed minus 1 is equal to 0. Okay, so we established, so we found one solution now, x is equal to 0. Okay, good. How about this one? Okay, this, you can rewrite this as a difference of two cubes. Sorry, yeah, two cubes, yes. You can write this as a difference of two cubes, or you can still solve it normally. So let me just do it both ways, right? So I have 27 x cubed minus 1 equals 0. We can bring the 1 to the other side. This becomes, so the sign is going to change. So we have 27 x cubed equals 1. So what can we do? We can find the cube roots of both sides. So what's going to be the cube root of 27x cubed? So the cube root of 27 is 3. So just find the cube root of both sides. Cube root of 27 is 3. Cube root of 1 is 1. So it's just 3x equals 1. And then we can divide both sides by 3. X equals 1 over 3. So we have x equals 0 or x equals 1 over 3. Now, some people would like to go through the difference of two cubes route. I mean, let me also do that. Let me kind of do that here. So we have 27 x cubed minus 1 equals 0. We can write this as 3x cubed minus 1 cubed equals 0. So based on the difference of two cubes, okay, we know that, where do I write this? We know that a cubed minus b cubed, we can write this as a minus b bracket a squared plus ab plus b squared. Okay, so considering this as your a and this as your b, we have, it's going to be 3x minus 1 in bracket 3x squared. I'll just write them directly. 3x all squared in bracket, that will be 9x squared plus 3x times 1 plus 3x plus 1 squared. Okay. All right, so we have 9x squared plus 3x plus 1. Okay, now, so we're going to have 3x minus 1 bracket 9x squared plus 3x plus 1 equals 0. So it means that either 3x minus 1 is equal to 0 or 9x squared plus 3x plus 1 is equal to 0. Now, this one has no solution. Okay, if you use the if you use this, because this looks like a quadratic equation, right? If you use the b squared minus 4ac, you see that is less than 0. Okay, that if you use the determinant is less than 0, so this has no solution. Well, this one, if you do this, if you find x, you're still going to get your x as 1/3. Just showing you all the steps. But in the end, we have our x equals 0 and x equals 1/3. So I'll just write it x equals 0 or x equals 1/3. Okay, now how do we find y? Let's go back to, well, we've done a lot, I've written a lot. Okay, remember the derivatives that we had. Hope you're writing, or hope you're following well. 3x squared minus y equals 0, and 3y squared minus x equals 0. So let's start with when x is 0, okay? So when x is 0, so let's use equation 1. 3, 0 squared minus y equals 0. So 0 squared is 0, and 3 times 0 is 0. Everything is 0. Okay. Minus y equals 0. Y is equal to 0. Okay. Okay, 0. Okay, 0 minus y is equal to 0. Y is 0. If you move the y here, 0 is still equal to y. Just y is 0. So it means that when x is 0, y is equal to 0. So you have something like this. Okay, this is your first point. Okay, you can see this is your first critical point now. 0, 0. Right, this is your first critical point, 0, 0. But when x is 1/3, okay, let me use this to the second equation just for, just that everything flows. 3y squared minus 1/3 equals 0. Okay, so we can move the 1/3 to the other side. Okay, it becomes plus. So we have 3y squared equals 1/3. So remember, we're looking for y squared for y, not just y squared. First of all, we need to get rid of the 3. And how do we get rid of 3? Divide both sides by 3. So this divided by 3 and this divided by 3 again. So this will be y squared equals 1/3 divided by 3. We can write this as 1/3 times 1/3. This gives us 1/9. So we have that y squared equals 1/9. And let's find the square root of both sides. All right, so it means that y squared, okay, y squared will be, so the square root of y will be, so the square root of y squared, square root of y squared is y, and the square root of 1/9 is plus 1/3 rather, just 1/3. Okay, so when y is, so when x is, well, 1/3, y is also 1/3. Okay. All right. Now you were saying now you could actually make the argument that why didn't you use the square root of as 1/9 could actually be plus or minus or as 1/3. Fair enough. Actually, that's fair. Okay, just that you can if you look at the other equation now, if you actually put it into, we have 3x squared. The first one minus y equals 0, because I looked at, like, I was kind of screening it in my mind. okay, equals 0. When you make your x as 1 over 3, so let's say 1 over 3 minus, and your y is minus 1 over 3, you're not going to get 0. Okay, just work with me here. Here you're going to get, this is 1 over 9, this is going to be 1 over 3. So this minus times minus gives you plus, plus 1 over 3 gives you 0. So, you just, so you're not going to get 0, you're going to get 2 over 3. Okay, so y is actually going to be 1 over 3. So it's a way to kind of screen out the wrong answer too, because you could actually argue that plus or minus 2, the square root of, of 1 over 9 could be plus or minus as 1 over 3. Okay. But after looking at the first equation too, okay, yeah, it's not going to work. Okay, it's going to be 1 over 3, 1 over 3. So it means that finally we've gotten our critical points. Wow. Our critical points are 0, 0, 1 over 3, 1 over 3. Oh, thank God. Woo. This is the first half. Okay, this is first half. Let's go for halftime first and come back for second half. Woo. So we've gotten the critical points. Now, the question says we should go, if you go up, we just need to, where's that one? Study their nature. So we hate to know, is this a minimum point or a maximum point? At least we've gotten somewhere. So the, in order to do that, okay, we use what we call the Hessian matrix or some matrix. I don't know, depending on which one you want to say. Okay. So what you're gonna have, you have like a 2 by 2 matrix. So in this case, you're gonna actually find the second derivative now. So write like this. Okay, so write f x x. Okay, f x y f y x f y y. Now I'll just put prime here so that I know that it's going to be like a derivative. Okay, so what this means is that you know the the derivative of the function, or let's say the partial derivative of the function with respect to x the first one time, with respect to x the second time. Here with respect to x the first time, with respect to y the second time, just like that. So you're gonna find the derivative. Find the derivative of the function twice, the first derivative and the second derivative. But the good news is that we already have the first derivative with respect to x and y. So just, okay. So we already have the first derivative with respect to x, which is 3x squared minus y. So let's start with the one that has a derivative with respect to x first. These ones, this one where the first partial derivative with respect to x, these two up here. Okay, now let's find the second partial derivative with respect to x and with respect to y. So this one, with respect to x, we focus on the x. Okay, this is going to be 6x minus 0. I mean, use the y as a constant here. So minus 0, we just leave it at 6x. So let me just write 6x minus 0, which gives us 6x. Nice. Okay, and how about with respect to y? So we take the x as a constant. That's going to be 0. Okay, minus, and what's the derivative of y with respect to y? Minus 1. That's going to be minus 1. Okay, so if we go back up, we're going to have 6x. We're going to have minus 1. Oh, sorry for going too far. minus 1. I'll still, write it in a new matrix, but I just want us to, to be able to follow. And, the first partial derivative with respect to y, we had 3y squared minus x. Remember this stuff that we did here? Let me go back up. These two stuff that we did here that we could, yeah. So this is the first one with respect to x, the first partial derivative with respect to x, and the first partial derivative with respect to y. So I'm just now doing the second partial derivative. So with respect to x, and with respect to y. So obviously, with respect to x, if we take the y as a constant, everything is 0 minus derivative of x with respect to x is 1, which is 0 minus 1, that equals minus 1. And with respect to y, this becomes 6y minus 0, which just gives us 6y. So it means that here we have minus 1, and we have 6y. So we end up having something like this. Okay. 6x minus 1 minus 1, 6y. Okay. Now we need to find the determinant of this matrix or matrix, anyone you want to call it. So how are we going to do this? Okay, follow me here. So it's going to be this times this. Okay, this like this times this minus this times this. That's how I like to say it. Okay, your top left times your bottom right. Okay, where you minus your bottom left times your top right. So it's going to be, let me it's good to put them in brackets. So this is going to be 6x times 6y minus -1 times -1. What's 6x times 6y? That's going to be 36xy minus what's -1 times -1. That's going to give you 1. So that's going to be minus 1. What we have is 36xy minus 1. These are our determinants. So what are we now going to do with these determinants? Okay, we're going to now test the critical points. We're going to test the critical point. Okay, so what are two critical points? 0, 0, 1/3, 1/3. I want to test it here. Okay, let's start with 0, 0, where x is 0, y is 0. So 36 times 0 times 0 minus 1. So anything times 0 times is going to be 0. So this is going to be 0 minus 1. And 0 minus 1 is minus 1. What does that mean now? Okay, when your determinant is less than 0, okay? When determinant is, because minus 1 is less than 0. When your determinant is less than 0, this means that we have a saddle point. Okay, when it's less than 0, okay, determinant is less than 0, we have a saddle point or like a saddle. Okay, good. Okay, so it means that this critical point 0, 0 is a saddle point. How about 1/3, 1/3? Let's try it. So we have 36xy minus 1, 36 times 1/3 times 1/3 minus 1. 1/3 times 1/3 is 1/9. 36 times 1/9. That gives you 4. So it's going to be 4 minus 1, that gives you 3. So is 3 less than 0? No, 3 is greater than 0. So we have a number that is greater than zero. What does this mean? Now, this means this could either be a minimum point, so that's a maximum point. Let me use a maximum point or a minimum point. How are we sure which is which? Okay, we know that this is it's not a it's no longer a saddle point. Okay, we know it's not a saddle point, but it could either be a minimum point or a maximum point. And how do we know which is which? It's where we have to go back to this. See this one here. This, I mean, let me even go back. Let me go up more. This. Okay, where you have the partial derivative first with respect to x and the second with respect to x. This will tell you, okay, after you've gotten your determinant, right? This will tell you, this will always tell you if there's going to be a minimum point. I won't say always because, you never know, but generally this would tell you that if this is a minimum or a maximum point. Let's look at it. This is actually 6x, right? 6x. I have 6x. Okay. And what is our x? Because we're testing at, where at 1 over 3, 1 over 3, right? So our x is 1 over 3. It becomes 6 times 1 over 3, where 6 times 1 over 3, that is 2. And because the number here is greater than 0, this is a minimum point. Okay, if you do this, if xx like this, or just use is greater than 0, you have a minimum point. If f prime x x is less than 0, you have a maximum point. As long as the determinant is greater than 0, the determinant of the matrix is greater than 0. Okay, as long as your determinant is greater than 0, if it's not, it's automatically a saddle point. Okay, but once your determinant is greater than 0, then you can now test these two. So since we got 2, its value is greater than 0, so we have a minimum point. So that means that 0, 0 is a saddle point. 1 over 3, 1 over 3 is a minimum point. And just like that, we are done. Okay, we've identified the two critical points, and we've also, given their nature. This is like a saddle point, or just call it a saddle, and this is a minimum point. Okay, at a minimum point, which I have to sneeze. At a minimum point, you have something like this. Okay. Right. So this is it. I hope I really helped. So going back, let's go back to the first. Oh, we've done a lot just on one question. Jesus Christ. Okay. But then again, determine the critical points of the following study nature. We've gotten it as, 0, 0, saddle point, and then 1 over 3, 1 over 3, which is a minimum point, and that's just it. Wow. Thank you for staying with me up to the end. It wasn't easy, but yeah, thank you.